Hello friends, Shivansh this side, and today I'm going to prove that how this NES till infinity is irrational. Okay, I'm going to tell you this today, that how it is irrational. So what do I mean is that why every zeta at s is irrational. Yeah, I mean the same only. So let me write up my target there. Here which comes. This is my target, what I will prove here in this video. So first of all, let me bring calculator 2. With me is this. You might have seen this calculator many places. So okay, let me drop down this calculator for a while. So first of all, I must explain you what is zeta SS, because I don't want the viewers who don't know zeta function ran away from this video, as I'm really unsuccessful. I am not getting views. That means zeta at s is simply infinite sum from n 1 raised to the power s. Simple. Anything complex? No. And like many mathematicians would obviously be knowing this, as zeta at s for 0 leads you to $1 million. Okay, let's get out of money today. So why zeta at s is infinite sum of n is 1 upon s, why this is irrational. Okay, everything till here is right, since I haven't done anything. So first of all, start with zeta at every even. You know, I have told you formula. Zeta at every even is in form of, I forget the formula, but the thing I remember is that there is pi 2n upon 2n 2 into 2n factorial. No, I really forgot the formula, but thing I remember is that there is pi somewhere. You might also be remembering. I know you haven't seen my video. Please see. It's in the how to invent an infinite sum. There's a formula to find zeta at every even, and it is in form of pi to the power 2n. So that means zeta at 2 is pi square upon 6. From that formula, I really forgot the formula, but I remember the value. Zeta at 4 is something, but it is in terms of this. Okay, so what do you see in every even zeta? Okay, let me write it neatly. I'm really writing like professor. And you might be remembering when I used to make video in start. In the beginning, I wasn't able to make zeta function sign, but now I am able to make. Okay, that's great. Pi for something. So for every even value, you find pi here. It's everything in terms of pi. Yeah. So what do you think? What do you see? That it is irrational square upon rational. Now you must realize that pi to the power nen can never be rational. Why? Can anybody tell me? If you knew it, comment the answer below, and I'm still telling you. Since pi is transcendental. Do you know the meaning of transcendental? Comment it down. I know I don't get comments, but still, what's the flaw in asking? Please subscribe my channel, please like my videos, and I don't need likes, but please give me views that how the hell I'm doing. So that means everything in terms of pi. Sorry, what I was telling, I really forgot. Yeah, what is transcendental? Okay, may I face the camera here? Transcendental numbers are numbers like they are real numbers, real which includes rational and irrational both. They are real numbers which can be never expressed in any polynomial, any algebraic polynomial as roots. For example, you see an irrational number root 2. Root 2 can be 0 of an algebraic expression if I wrote it in simple numerical forms in rationals. That means if the any equations has rational numbers, then the root this can be, then the irrational root can come out to be. But I challenge you here right now, I will give from my pocket 5 rupees. So I really don't have. If you show me any equation with rational numbers whose root is pi or e, you must be knowing pi, we are studying from class in CBSE from class 6th. E you will study in class 11th, or you might have studied 718 something. Euler's number. Who the hell is he? Okay, so let's start. 1 upon 1 to the power s plus 1 upon 2 to the power s 1 upon 3 to the power s is irrational. Yeah, so how do I prove this? Let's take the value of s as 2. Okay, that means 1 upon 2 1 upon 1 ki power 2 plus 1 upon 2 ki power 2 plus 1 upon 3 ki power 2, it tends to irrational. Now you would saying that you know it's pi square upon 6, but how I'm saying it irrational? See it right here. Let's start from 1. What is 1 upon 2 ka square? That's why I brought the calculator. Okay, for this value I know it. 0.25. 1 upon 9. 1 upon 9. 1 upon 9. I hope you are able to see the value. 1 and similarly 1.60 1 upon 16. I don't know why the hell 7 is 0.625. 0.0625. Now here you see it tends to 0. Okay, it goes till 0. Limits, simple limits to. So you see, for the first, like if I draw place value chart of decimal, at 2 it's 25, 1 1 1 1 1. Now here came 0. Okay, that means here the story ends. 625 for next value something 0, then 0 0 0 0 0 something, like here it would be in the form of this 0.0 something something, then 0 0 0 something something, then 0 0 0 something something. Okay, you see here it won't repeat itself, since the miscellaneous digits are adding themselves to get me pi square upon 6. Along with it, why it won't terminate as sum of rational is rational, since the number of zeros is going here at infinite at 0.001 at very small number than infinite, then here would be some value. Okay, you see it would be ramble up like this. If I put up the value, that means that's the reason. I hope I am able to make you understand. As it is going from here, and the 0 it's here, and it would be, and the 0 would go there. 0 0 0 here, 0 0 0 0 here, but the digits would be there, like after some zeros. And since it is for infinite, there would be many zeros till last, which would lead you to 1 2 something something. And since it's infinite, what is infinite? It never stops. And what is irrational number? It never terminates. So that means I goes on this calculation infinity. I get number here, I get number here, I get numbers till infinite. So that's the basic reason why zeta at every s is irrational. So what are the two reasons I told you? For even zeta, due to pi. One more reason, the basic, from which you can prove that zeta at 3, zeta at 5, zeta at 7 is also irrational, by the basic property, which states that, what does basic property states? That since the irrational number never terminates and it is going till infinity, the summation is till infinity, is in form of 0 0 0. That's why. And now I would show you the third method too. You know what is zeta at s into gamma at s? Yeah, is what? Okay, I'm really not sure of this proof. It's just a tukka, wild guess, because I'm really damn sure about my first two proofs, but I'm really not sure about this proof. You know it is rational. No need to prove irrational. Here, the basic thing is that zeta rational implies to this, like zeta into rational into in any rational number which is in form of gamma into zeta is this. Okay, so what I find is there is a transcendental irrational number e, which destroys the rationality of this integral, and that's why the thing which would come up here is irrational too. So that's why I concluded up with that this too is irrational. And in these three ways, which is number one, even it is in form of pi to the power even. Thing number two is the basic thing, in which I will say that that 1 upon 7, that 1 upon any number, it is at one time there are some digits here leaving 0, then there is 0 point some digits here leaving 0, 0.00 some digits here leaving 0, and there is no considerable series which you can put up which can imply it here. Okay, I'm not scolding, and I'm pretty confident that this mic is very strong. So sorry I caused a damage to your ears. Sorry. And the third was integral proof. And yeah, please confirm me for this proof too. Thank you. I am really tired asking you for this thing. Please like my video, please subscribe my channel, and please share this. Like what's the flaw in this proofs? I'm really mad. I'm working out on these every day, so please show some support. And what do you need to show support? You're seeing that red button below this, like you're seeing just below red button of subscribe it, and just beside is a bell, Santa's bell. Press that bell, and please subscribe my channel, like my video, and thanks for watching.